Review question 2. Solve the following equations. So likewise in question 1, to solve indices, I have to make sure that both sides, I try to make the base the same so that I can compare their powers and solve from there. So for part A, 9 to the power of x plus 2 equals to 27 to the power of 3 minus 2x. So for the base of 9 and 27, what is the common base over here? Okay, 9, I can change it to 3 square. And 27, I can change it to 3 cubed. Okay, from here, 3 square, don't forget about the x plus 2 equals to 3 cubed. Don't forget about the 3 minus 2x. Okay, so from here, each one, I will use the law of a to the power of m, bracket n, which is a to the power of m times n, which is a to the power of mn. All right, I'll be using this law for both. Gives me 3 to the power of 2, bracket x plus 2. Later on, I will have to rainbow it in. All right, likewise for the right-hand side is 3 to the power of 3, bracket 3 minus 2x. Same thing, I will have to rainbow it in later on. Okay, now from here, to further simplify, I will rainbow it in for the power, which gives me 2x plus 4 equals to 3, 9 minus 6x. So from here, it's easy already because I have my base to be the same. I can just compare the power and it becomes a linear equation. So 2x plus 4 equals to 9 minus 6x. From here, x on one side, numbers on the other side, 2x. I'll bring the minus 6x over to become a plus 6x. 9, I'll bring the plus 4 over to become a minus 4. So this is 8x equals to 5. And x is equals to 5 over 8. Okay, so this is my answer for part A. And for part B, same thing. 16 to the power of 3x minus 1 times square root of 32 equals to 1 over 4. So taking a look at all these bases, I have 16, 32, and 4. What is their common base over here? Okay, common base for all this will be a base of 2. All right. So for 16, I can change it to 2 to the power of 4. 3x minus 1. And for 32, it's actually a base 2 to the power of 5. And for 1 over 4, I can change it to 1 to the power 1 over 2 to the power of 2. Okay. So now I have changed all the base to a base of 2 already. I have to further simplify this portion over here first. Same thing for this. It's a multiplication. Okay. What about this rational indices over here? When I have a square root, it is actually to a power of 1 over 2. All right. So 2 to the power of 5, 1 to the power of 1 over 2. And how do I make this fraction to a non-fraction form? Remember for question 1, to pull denominator up, I have to change the sign of my power. Remember, it's the sign of the power, not the sign of the base. Okay, so 2 to the power of a negative 2. Okay, and then I will rainbow this part in to further simplify it to give me 12x minus 4. And this part, I will multiply them, which gives me 2 to the power of 5 over 2 equals to this one. I'll just copy it back. Okay, from here, how do I combine these two indices? Remember the law of a to the power of x times a to the power of y, which gives me a to the power of x plus y. Yeah. Same thing, because of the base is the same already, I can just add the power together for multiplication. So if it's a division, then it's a subtraction for the powers. So it's 2 to the power of 12x minus 4 plus 5 over 2 equals to 2 to the power of minus 2. Okay, now for my left and my right hand side, I have the base that is the same. I can just drop the base and I compare the powers and continue solving them from here. Okay, so it's 12x minus 4 plus 5 over 2 equals to negative 2. So x on one side, which is 12x, and I'll bring all the constant term to my right-hand side. So it's minus 2 plus 4 minus 5 over 2. So just keep in mind, when I bring terms over from my left-hand side to my right-hand side, I will always have to change the sign of them. So it's 12x equals to negative half, and x is equals to negative half divided by 12, which is equals to negative 1/24.